Sorry, I missed you guys today. I know we're behind, so that's why I'm making a video so we don't get even more behind. Today we're going to talk about the power rule and higher derivatives. Now, you may hate me or you may love me after I show you the power rule. There's a little warm up here, so take a couple minutes. I just posted the answers there, so if you just take a couple minutes, do that warm up, make sure you understand those questions. And there's another one after that. So after you finish those, then you can come back to the video and whatever, but just take a second and look those over. So let's recall what a derivative is. Remember that derivative is just the slope of your tangent or slope of your curve. Okay, and we also call that your instantaneous rate of change. So anytime they ask you for the instantaneous rate of change, they ask you for the slope of the curve at a certain point, that's when you're looking for your derivative. So IRC, instantaneous rate of change. Now, before the lesson before, we looked at the formal limit definition of a derivative. So if the question asks you to find the derivative using the limit definition, that's when you're going to do the limit as h approaches 0 of f of x plus h minus f of x all over h. So what I'm about to show you now is basically your shortcut if they tell you just find the derivative. So if they don't specify that you need to use the limit definition, then you can use the power rule, which I'm about to show you. So what I did was I took all of the functions that we talked about last class and I wrote them all down, and then I wrote their corresponding derivatives down. So what we did last class was I gave you a function, you found the derivative using the limit definition. Okay, now if you take a look at all of these, there's a pattern that starts to occur. So pause the video, take a look at all the functions and their derivatives and see if you can't come up with a pattern. If you think you've got the pattern, go ahead and play back your video. So what I'm hoping that you noticed in the patterns was that there was something to do with the exponent and the leading coefficient. So the power rule states that if you have a function, so if we have f of x, and it is equal to x raised to the n power, then your derivative, f prime of x, would be equal to n times x raised to the n minus 1. If you have, so there's a couple different scenarios you could have here. So if your function is equal to just a number times x, so this could be like, well, before I go on to that, let's just do a quick example up here. So example, y equals x squared. So if y equals x squared, then I would take the exponent 2, bring it out in front, and now multiply it. So the derivative would now become 2x. And then notice I subtracted 1 from the exponent, so it just became 2x to the first. So let's say we had a function that's just cx, c being an integer value or just a coefficient value, it's just a number. Then your derivative would just be c. So for example, if I had y equals 3x, then my derivative would just be 3. If my function is just a number, then my derivative is equal to 0. So for example, if I have y equals 5, then the derivative is just 0. Okay, because technically this is 5 times x to the 0, and then if you did 0 times 5, you'd get 0. Okay, so this is just, that's how that rule works. So now let's put this to work. So if I had asked you last class to find me the derivative of 7x cubed minus 4x squared plus 7x minus 10, you would probably do a whole lot of groaning and grumbling, and then you would eventually come up with the limit. However, now that we know the power rule, it's a whole lot easier. So the derivative, you're going to do 3 times 7, so that's going to give you 21. X, you're going to subtract 1 from the exponent, so squared. Then you're going to move on to the next term. 2 times 4 is 8. Subtract 1 from the exponent, it's going to be to the first power. Plus And then this is really to the first, so this is just going to end up being 7, and then your constant doesn't end up being anything. So had we done the limit as h approaches 0 of f of x plus h minus f of x all over h, you would have ended up with 21x squared minus 8x plus 7. Power rule, a little bit easier. Sometimes it helps you to rewrite them. So this is the same as y is equal to 3x squared minus x to the 1/2 power plus 4. So if I want to write the derivative of that, it's going to become 6x minus 1/2 x raised to the negative 1/2. Now, you want to always write your derivatives with positive exponents. So your derivative is going to become 6x minus 1 over 2. It's going to be raised to the positive 1/2, which is the same as taking the square root. This is how you want to leave your answer. This one I'm going to rewrite with negative exponents before I take the derivative. So this is x to the negative 1 plus 4x to the negative 2 minus 3x to the negative 3. So what I want to do is when I take the derivative, this is going to help me when I subtract from my exponent. So my derivative is going to become negative x to the negative 2 minus 8x to the negative 3 plus 9x to the negative 4. Again, you want to rewrite with positive exponents. So your derivative is negative 1 over x squared minus 8 over x cubed plus 9 over x to the 4th. So that's how you want to write your derivative there. Okay, last one, just a little reminder, power over root. I know it's been a while since we've done that. So this is the same thing as y equals x to the 1/4 power minus x raised to the power over root, so 3/5. Okay, so now when I write the derivative, it's going to be 1/4 x, and now you're subtracting 1, so this is going to become negative 3/4 minus 3/5 x, and then you're subtracting 1, so that's going to be negative 2/5. Then you're going to rewrite it with positive exponents. So your derivative is going to be equal to 1 over 4 times the power over root. So that's going to be the 4th root of x cubed minus 3 over 5 times power over root. So this is going to be the 5th root of x squared. Okay, and that's how you would want to leave that answer. So at this point now, after I have showed you the power rule, you either love me because I just showed you a very quick shortcut, or you hate me because I made you go through the formal limit definition the other day. All right, on the next page is some examples for you to try on your own. So I've just listed all of the answers. So those would be good questions for you to try out. Make sure that you can use your power rule. At this point on a test or a quiz, if I ask you to find me the derivative, if I don't specify, give me the derivative using the limit definition, you can go ahead and use the power rule. Okay, higher derivatives. So now we're talking second, third, fourth, seventh derivative. The only thing that changes here a little bit with your notation is that you add more primes. So f prime of x would be the first derivative. If you had 2 primes or double prime, that would be the second derivative. Now this continues on until you get to 4. So 3 is the only one that you'll see. That's the highest you'll see with prime. Then they're going to raise it to the 4th. So this would be the 4th derivative. So this y to the 7th, that's your 7th derivative. So each time you do this, you can just use your power rule. So if y equals x to the 6th, the first derivative would be 6x to the 5th. The second derivative would be 30x to the 4th. The third derivative is 120x cubed. So as long as you can multiply, this is pretty easy. The fourth derivative now becomes 360x squared. And as you go on to different derivatives and we get into different lessons, you'll learn, your first derivative helps you with your slope. Your second derivative, that's going to start helping you talk about the concavity of your graph. So each one of these derivatives has a purpose. All right, we are up to the 5th derivative here because we have to go all the way to the 7th. So 720x. 6th derivative, 720, and then your seventh derivative would just be 0 in this case. Okay, so sometimes you can get to 0 depending on whatever your exponent is when you start. Okay, so your second derivative is really just the derivative of the first. So you're just repeating the power rule each time. Okay, so it wants you to find the first, second, and third derivatives for each one of these. So I'm going to do the first one for you, and then I want you to try the next two on your own. So the first derivative would just be 2x. The second derivative in this case would be 2, and then your third derivative would be 0. Okay, so I just used the power rule over and over. So before you start this next one on your own, try rewriting it as 2 times x to the 1/2. That may help. Okay. All right. So go ahead and, and I'll give you a hint for number 3 too. Rewrite that as y equals 2 minus 2x to the negative 1. Okay. So I want you to find me the first, second, and third derivatives for each one of those. Okay. How did you guys do? Take a second look over everything. Now I kind of skipped a couple things. So when I did, for example, on number 3, when I did my first derivative, I got y prime equals 2 plus 2x to the negative 2. Okay, so no, I did not get 2 plus. I just got 2x to the negative 2. Sorry about that. Get rid of that too. Okay, so I just got 2x to the negative 2. Now, when you go to do your next derivative after that, because you want to write your first derivative, you want to write your derivatives with positive exponents. So this became 2 over x squared. But when I went to write the next derivative, I went back to my negative exponent. So I used my first derivative. And then from here, I said, well, that's equal to negative 4x to the negative third. And then I rewrote it with positive exponents. So you might want to, if you've got to do a couple derivatives, it's easier if you leave the negative exponents. Okay. Now the rest of the questions here on your notes, I've gone through and filled in all the answers. So now it's the same type of questions that we've been doing, except now you're allowed to use your power rule. So basically less work. So you can go ahead, the rest of class, you can go ahead and work on those. Okay, and then I will be back to see your beautiful faces. Oh, I don't see you tomorrow because it's a D-Day. So that means I won't see you till Thursday. Okay. I will miss you guys terribly today. I hope you enjoyed this fun-filled, thrilling, exciting video. Have a good day, guys.